All right, so what we're going to be looking at now is what's called orbital diagrams and writing electron configurations. So when you're looking at the periodic table, you can identify elements and you can write configuration. Well, first of all, you need to know a little bit about the orbitals, okay? Now, with this information, you have an s orbital, which holds, it's one orbital. So this is my orbital, and this is my number of electrons. It has one orbital and 2 electrons. You have a p orbital, which means 3 orbitals, 6 electrons. You have a d, which has 5. That means it holds 10. And you have an f, which has 7. And it holds 14. So basically, every orbital holds 2 electrons. And depending on how many orbitals you have is going to depend the total amount of electrons that it holds. All right, so let's look then at electron configurations. So I gave you several rules, actually 3 rules. So first was Aufbau. Aufbau says you have to fill the lowest energy level first, okay? Then you have Hund's. Hund's rule states that you've got to fill single orbitals before you pair. And then Pauli's rule was that you have to have opposite electrons, meaning positive and opposite spins, okay? So I kind of explained this that day using an apartment building. So if you're an apartment owner, what you try to do is you fill your first floor first before you go to the next floor. You fill it up, all your single rooms, before you start to make double rooms. And then there has to be opposite gender, male and female in each room. So that's what those rules are. So now what we can do is let's go ahead and try and write a configuration based on these rules. So we know the orbitals. We know that there's rules in filling them. So let's look at, and I'm going to use blue. Let's look at calcium. Okay. So calcium, the first thing I look at is on the periodic table, I find its atomic number. It has an atomic number of 20. So if it has 20 protons, then it has to have 20 electrons. Okay. So you're going to start right here. 1s is going to have 2, because remember, 1s orbital holds 2 electrons. So go ahead and fill up everything. Okay. So from 1s, I go to 2s. Notice I put both arrows. Then I go to 3s. Okay. I'm sorry, not 3s, 2s and 2p. All right, follow your staircase. Now I'm at 3s. So I need both arrows, because look, right now I've got 6, 8, 10, 12 electrons, and I need to get to 20. So I'm going to go now to my P. Notice these are little arrows. They don't look like it because the way I'm writing, but they're just, I'm trying to do it like this, little arrows. All right, so I'm at my 3p. Well, at 3p, I have 18 electrons, so I need 2 more. So that's why I'm going to stop here at my 4s. Now, write your configuration based off this. So 1s, 2, 2s, 2, 2p, 6. Let me get rid of this. All right, 3s, 2, 3p, 6, 4s, 2. So that's how you take, so when you're doing this, that's the orbital diagram. When you're doing this, that's the electron configuration. Now, let's say I wanted you to do an abbreviated configuration. Well, an abbreviated configuration is you find the noble gas that comes before calcium, and that would be argon. So then I would just say argon, so AR, meaning that calcium has everything argon has, because if you look, argon is this, okay? So all I'm doing is substituting in AR. and then I write what I have left, which is 4s2. So this is, when you hear me say full electron configuration, I'm talking about this. When you hear me say abbreviated or noble gas, I'm talking about this one. All right, let's do another one. All right. Let's do a D block one. So let's do zirconium. Zirconium is 40. Okay. So once again, that 40 lets me know that I have 40 protons, so 40 electrons. So I'm going to start right here. Okay. Keep going. All right. If I stopped right there, I have 10 electrons. So I need to keep going because I've got to go to 40. So follow your staircase. Okay, so if I look here at 3D 10, I've got 30. I need 10 more. So from 3D, look at your dashed lines. You're going to go to 4P. Okay, I need all 6 of the 4Ps. So now I'm back at 5S. All right, 5S2 would give me 38. So I need 2 more. So I'm going to go to 4D. And that's going to be my that is my orbital. Remember, this is my orbital diagram. Okay. If I want to do my electron configuration, just rewrite it. So 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2. Oops, I didn't. Did y'all see my mistake? Whoops, let's make, so 3p6, 4s2, 3d10, 4p6. And look, I'm glad I made that error, because if you're looking at a multiple choice question and you see that it's not in the right form, then you know it's wrong. So from 4p6, I go to 5s2, and then lastly, I finish up with 4d2. All right, so that's my full configuration, which notice that that's pretty long. So let's do this in abbreviated. So abbreviated configuration, the noble gas that's in front of zirconium is krypton. So I would put krypton, and krypton's going to end in 4s2. So, sorry, 4p6. So here to here is krypton. That's why we call it an abbreviated, because we're taking everything that krypton has and we're just saying krypton. And now I just write what I have left, which would be 5s2 and 4d2. So that would be the abbreviated. This is the full configuration, and this is the orbital diagram.